So let's get started. Welcome to a new week, to a new topic. Last week we mainly focused on asynchronous programming, and I hope you can remember what we did last week because we are going to need it once we come to the topic of entity framework and data access and so on. Today we are going to talk about the second very important base technology that is super important when it comes to querying databases. We heard a lightning talk about the topic today, so you have already a little bit of background knowledge. That's very good because I can build on that. But we will dive in deep into LINQ and take a look how it works, try to understand what the basic technologies behind LINQ are, and then we are going to practice a little bit. So we will take one of the homeworks that you did and we will implement it together based on LINQ, and if there is still time you can start working on the homework which is due to next week, okay? But first we'll talk about the basic technologies behind LINQ. If you would like to follow along, then please create a new project, and as always we are going to use a console app in .NET Core. I'm going to call it Hello LINQ. Let me start my zooming tool so I can zoom in a little bit. Here it is, Hello LINQ. Nothing special. Just a plain old console app. Should be done immediately. Here it is. And then please remember, go to Properties or in the CS proj file, as we do it always, and switch to .NET 5. I also ask you in the project file, you can remember it from last week and the week before, go to LANQ version preview in order to get the latest C# features enabled in our program. And with that, we are good. If you get annoyed with this whole namespace class, main and so on, I think by now you should be familiar with that. In C#9 and .NET 5 you can remove all the main stuff, and with that you have a nice clean little field for experiments, and this is exactly what we need. Good. The first thing that I would like to describe and discuss with you is the concept of IEnumerable. Who knows what the members of IEnumerable are? IEnumerable is an interface, so it has some members. Which ones? Okay, that's a tricky one. It only contains one member, get enumerator. So let's talk about the enumerator. What are the members of an enumerator? Guess. Any idea? Yeah. List? No? Yeah.
I think it's just an ID.
Just an ID? No. Yeah.
Current.
Current, correct. With current, I get the current element. So I have a pointer in any kind of collection, and with current, I get the current item. What else? If I have current and I have an enumerator, Aufzählung, to enumerate is aufzählen. What do I need?
Reset.
Reset? No, not possible. Yeah. Exactly. Current and move next. That is what you have. There is a good idea with the reset thing, but it's not there. So you have a forward only, read only cursor through a collection. You can ask for what is the current element, and you can say go to the next one. If you go to the next one and there is no next one, then you will get false as the return value of move next. Got it? That's IEnumerable. Read only, forward only. You cannot manipulate an IEnumerable. Not possible. You cannot go back. You cannot reset. You cannot jump. You cannot access with an index. That's not possible. Just move next and current. Good. Good. Let's implement a very simple Enumerable generator. The first code that we are going to write is not very good. So we are working our way through to understanding what Enumerable really is. So let's create a function which will return Enumerable of, let's make it very simple at the beginning, just an integer value. Enumerable of int, generate numbers, and it will get an int max value. So we should generate all numbers between, let's say, 0 and the max value. A naive implementation of this method could look like this. Var result equals new list of int for var I equals 0, I lower than max value. Oh, it doesn't matter. Lower equals, not relevant for this example. I will say lower equals. Result.add I return result. Now, why can I return a list? Because if we take a look into list of t, we scroll up a little bit, then you will see that list of t, see it here, implements Enumerable. You mentioned that in your lightning talk. I like that. Any class that implements Enumerable can be used as a basis for LINQ. Good. So we just return the list. Very, very simple. Now remember the lightning talk that we just heard about LINQ. Let's build a very, very simple query. Let's start by calling generate numbers, this one, give it a max value, let's say of 10, something like this. And then if we do a look using system.LINQ, we now have a method, you mentioned it in your lightning talk, which is called where. And here we can specify a so-called predicate, a func of int and bool. And my question to you is, that's a repetition, you should already know that by now. Func of int and bool gets which parameters? Yeah, correct. And what is the return type? Bool, correct. That's exactly the case. So let's give it the name n. You can choose any variable here. It's just a variable name. And in this case, let's say only even numbers. Got it? Very, very simple. Let's store the result in a variable. And then let's iterate over this variable. For each var item in result, console write line item. Got it? Difficult? No, I don't think so. You should understand what this where is all about just by taking a look at it. I mean, can you remember what I told you? I think, did we discuss the whole Aschenputtel Cinderella stuff where I told you, did we discuss that? No? Yeah, okay, that doesn't matter. Just this function is applied to each number and it is only returned if this condition is true. So let's give it a try. Let's run this method or this program. And the return is all even numbers. 0, 2, 4, 6, 8, 10. Yep, that looks good. Can I assume that we don't have any severe questions to this code? You can read it, you can understand it, not big of a problem, right? Good. Now we are going to dive a little bit deeper. We are going to think about how Enumerable really works. And to do that, the first thing that I would like to do together with you is I would like to refactor this method. I would like to get rid of the list here. So please delete the var result equals to new list. I want to get rid of that one. Then we don't have a result anymore. We cannot add it to any kind of result. We cannot return the result. There is no result. So which C# keyword comes in handy in this situation? Correct, yield. So what we can do is we can say yield return I and remove the return here. Yield return is a really interesting guy. Yield return will return the value without us having to create a list or an array or something like this. Yield is called ernten in German. Okay? If we run our application now, it should still work properly. Nice. We will debug that in a second, okay? Just accept what we have written here. You can remember, instead of creating a list or any kind of collection that stores our value, we can just write yield return, and it magically happens. We will take a look at how C# does that. Now let's restructure our program a little bit. Let's please put this one in a block of code. So it should look like this. I'm just putting in some brackets. See, it's exactly the same code as before. The only difference is that I now have a block of code that makes it easier to debug this stuff and to set a breakpoint. It would be possible with the other syntax too, but it's easier like that. And just to make it a little bit more interesting, we are also going to select to project the values. We heard it in the lightning talk. Thank you for the good preparation. We can say here, select, and here we just say, oops, this is the right one, return n multiplied by 2. No, multiplied by 3. Sorry. If I run it, it's good. Looks good. So I give you a second so that you can change your code accordingly. This is what I want you to change, this is what I want you to add, and this is where we have the yield. And then we are going to discuss what's the point of all this. Does anybody need additional time to write down the code? You're fine? Good. Now let's set a breakpoint here in line 24. You can do that by pressing F9 or by clicking in the gray bar here. Let's please select, set a breakpoint here inside of the select. Set a breakpoint here inside of the return. And set a break inside of the where, sorry. And set a breakpoint here inside the for each. So we should have 4 breakpoints. In the where, in the select, in the console right line of the for each, and in the yield return. Good? Good. And then run the program in the debugger, so press F5. Not Control F5, but F5. This runs the program in the debugger. And we are going to stop inside the generate numbers yield return. Now, how did we come here? There is a tool in Visual Studio, I'm not sure if you are familiar with it. It's called the call stack. No, here's the call stack. I hope you can find it. Can you find it? Call stack? Yes. Good. And if we take a look, we see in the call stack how we came to this generate numbers. We came from the main method, line 15. So if we click on that, double click on that, it will show us where we came from. And this is pretty astonishing what we see here. The call to generate number, now look at the screen, that's important, did not happen here. Generate numbers was not called when we seemingly call generate numbers. It didn't happen. The call of generate numbers happened inside the for each loop. You see that one? How can that be? What's going on here? I mean, we have learned for months and years that when we write a syntax like that, we are calling a method, right? But we don't. I can prove that to you. Let me show you. Please stay in the debugger, okay? Just for me. I go through, if I press F11, it will walk through the code. You see, here I'm now standing at the call of generate numbers, and I press step into. So I would like to see what's going on, and it jumps over the entire statement. It ignores the method call. What's going on? And now we are here in the for each statement, and only when we are here in the in statement, it really jumps into generate numbers. You see that? It jumps into generate numbers, and it would yield the first return value. This concept is crucially important for you to understand Enumerable. It is super important if you want to successfully use Entity Framework. The whole idea that you see here in action is that Enumerable is a pull-based system. That means if we call a so-called generator method, a method that generates an Enumerable, the method is not really called. It is not. It's just sitting there, idle, doing nothing, until somebody is really interested in the result. So the generator method is completely inactive until somebody says, and now I need the first value. The for each loop is the guy who really says, now I need the first value. And what happens behind the scenes when for each starts running? The move next method of the Enumerable is called for the first time. And only when Enumerable move next is called, the generator method is called. Get the idea? Not before. So what we can do is we can build queries step by step by step. You will see that in a second. And only at the very end, when we start getting values, then our generator method really becomes active. What would be the opposite of a pull-based approach? A push-based approach, right? Do you know any design pattern where this is flipped around, where we don't have this pull thing, where the values are generated when we pull the first results, with the for each loop, for instance. But the difference is that the values are pushed as soon as they become available. What is the name of this design pattern? It starts with O. Yeah? Yeah? Observer. Exactly, the observer pattern. The observer pattern is the difference, is the opposite of the enumerable. Observer means that you have an observable, you have a subscriber, and the observable pushes its value to the subscriber. By Enumerable, it's different. The generator is inactive until somebody is interested in the result. Okay? It's like with your homework. I give you the homework and you don't start immediately working on the homework. Only when I say I want to see the result, then you start working on the homework. Get the idea? Yeah, you know what I mean. Now, let's go one step further. Please press F11 and let's see what's going to happen. If we press F11, the next step is now the where clause. You see that? So we are returning from here. We are really leaving the generate method. Please watch that closely and try to understand what I'm telling you here. The generate method does not generate the entire numbers array. It generates only the first value. And then the value runs through the entire pipeline of filters, select clauses, and so on. Please give me just 2 or 3 more minutes, then we're going to make the break, okay? So if we press F11 again and F11 again, so we run through the where clause, and now see what's going to happen next. Next we are going to run through the select clause. So we finish the processing of the first value. You can continue to press F11. Now we are printing in on the screen. You see it here? So we finish dealing with the first value, 0 in our case. And now watch what's going to happen once we reach the in clause again in the for each loop. Guess what? It jumps again back to the generator method. You see it? But it doesn't jump into the beginning of the get enumerators, get numbers, but it continues after the yield. So what we see here is that a generator method with yield yields the first value, returns it, then it runs through all the different LINQ operators, then it is processed until the very end of the query, in our case the for each loop, and then C# automatically jumps back into the generator and says, now I need the next value. Understand it? That means, give me a second, that means that if you generate a large number of items, for instance numbers, you don't have a memory problem. You never have the situation that all the numbers are in an array or a list, because they are generated one by one by one by one. They are processed, each element, from the very beginning until the very end, and then the next value is generated. You have a question?
Is this only when you use yield, or also when you use a normal return statement?
When you use a normal return statement with the list, then the list implementation is doing the yield for you. You just don't see it. But it's suboptimal because you are taking, in our case, 10 integer values, which is 40 bytes, plus the overhead that you need for the list data type. So you have a lot of bytes in memory, but you don't need these bytes in memory. You can process one integer after each other. And that's a big advantage of LINQ. Got it? That's one of the fundamental principles on which LINQ is built. And after a short break, we are going to continue our experiments. So we are going to think about how this is all done and what the operators do and so on. So we are a little bit over time, 2 minutes. Let's continue. Yeah, it's easier. Let's continue at 9, okay? That's 8 minutes break, so you have the possibility to fetch a coffee or whatever. Good? 9 minutes.